Hello Honors Chemistry students, this is Mr. Spurk, and this is your Chapter 10, Section 3A notes on percent composition. Now percent composition is just the relative amounts of the elements in a compound, or the percent by mass of each element. So when we calculate a percent, we always take the part divided by the whole times 100. So for example, to figure out the percent you got correct on a quiz, you would take the number correct and divide it by the total points and multiply by 100. So when we need to figure out the percent composition of each element in a compound, we take the part that is, for example, potassium, and divide it by the whole mass of the compound. So you can see over here off to the right the breakdown for potassium chromate. So here's our equation, and all it is the mass of the element divided by the mass of the compound times 100%. So again, all it really is part divided by whole times 100. So let's look at an example. So in a 13.60 gram sample of a compound containing only magnesium and oxygen decompose, 5.4 grams of oxygen is obtained. What is the percent composition of the compound? So we know that we have a 13.6 gram sample and that sample is mg something O something. We don't quite know what the ratio is. But, so we have 13.60 grams of compound MgXOY. And we know that when it decomposed, we got 5.40 grams of oxygen. And we want to find the percent composition. But we also need to know how much magnesium we have. So to do that, we can subtract these two values. So 13.60 minus 5.40 is 8.20 grams, and that is how much magnesium was obtained, because these two elements come together to make this compound. So now all we need to do is find the percent composition of each. So the percent that is O is 5.4 grams of O divided by 13.60 grams of the whole compound times 100. And then we'll do the same thing for magnesium. So 8.20 grams of Mg divided by 13.60 grams MgXOY times 100. And when we go ahead and solve these, so 5.40 divided by 13.60 times 100, we get 39.71%. And when we do the same for magnesium, we get 60.29%. Now, percents are all based on 100, so this should add up to 100%. And if you go ahead and calculate that, looking at sig figs, we have 100.00%. So we must have done this correctly. With this example here, it says when an 11.4 gram sample of a compound containing carbon and oxygen decomposed, 6.84 grams of carbon is obtained. What is the percent composition of this compound? So I'm going to let you go ahead and do this one on your own. The video will pause and you'll have Edpuzzle ask you to input your answer. So go ahead and put the percent for carbon first, then a semicolon, and put your percent for oxygen. Or maybe it'll be a multiple choice. So to get you started, you have 11.4 grams of your whole sample. And all you know is that you have 6.84 grams of carbon. All right, so you can also calculate the percent composition of a compound using its chemical formula. The subscripts in the formula are used to calculate the mass of each element in a mole of that compound. And using the individual masses of the elements and the molar mass, you can calculate the percent by mass of each element. So, for example, it's pretty much the same thing, except now we're doing it within a known chemical formula. So, for example, propane is the fuel that's commonly used in gas grills, and we're going to calculate the percent composition of propane. So the first thing we need is the molar mass of the compound. So we need to calculate the molar mass for C3H8, and that comes out to be 44.09 grams per mole. And then we just need to figure out the percent of carbon and hydrogen. So we pretty much do the same thing here. The percent that is carbon is equal to 3 carbons times the molar mass of carbon. And again, I'm just getting that 3 carbons from the chemical formula here, divided by the total mass of our compound times 100. When we calculate that, we get a percent of 81.71% carbon. Now let's do it for hydrogen. And yes, I realize we could just take 100 minus that value, but we want to make sure that we're correct. We have 8 hydrogens times hydrogen's molar mass, which is 1.008 grams per mole. We're going to divide that by the total mass of propane. Multiply that by 100, and we get 18.29% hydrogen. Now one more time, just to make sure we are correct, let's add these up together. We do get 100.00%. So again, we know we did this correctly. So you can use the percent composition to calculate the number of grams of any element in a specific mass of a compound. And this will become really important when we start our next chapter on chemical reactions. To do this, multiply the mass of the compound by a conversion factor based on the percent composition of the element in that compound. So we just determined that propane is 81.71% carbon and 18.29% hydrogen. You can use the following conversion factors to solve for the mass of carbon and hydrogen contained in a specific amount of propane. Now, we are saying that we have 81.71% carbon. So what we can do is we can assume or set up a ratio of this amount of carbon for every 100 grams of propane. So our conversion factor for carbon is going to look like 81.71 grams of carbon for every 100 gram sample of propane. And you know that we can reverse that if we need to. And then for hydrogen, we have 18.29 grams of hydrogen for every 100 grams of propane. And these will be important conversion factors as we continue to move forward. So now we want to calculate the mass of carbon and the mass of hydrogen in 82.0 grams of propane. So what this is saying is we have a sample of 82 grams of propane. I want to know how many grams of that sample is carbon and how many grams of it is hydrogen. So all we do is we start with what we know, 82.0 grams of propane, and use our conversion factor. We just said that carbon is 81.71% or grams of carbon for every 100 grams of propane. Grams of propane cancels with grams of propane, and we're left with grams of carbon, which is great because that's exactly what we're looking to get. We're going to get an answer here of 67.00 grams. I'm sorry, just 67.0 grams of carbon. But I also want to know the mass of hydrogen, so we do the same thing. Of our 82.0 gram sample of propane, there are 18.29 grams of hydrogen for every 100 grams of propane. grams of propane cancels with grams of propane, and we get 15.0 grams of hydrogen. So in our 82.0 gram sample of propane, we get 67.0 grams of carbon and 15.0 grams of hydrogen. Now again, we can always check our work. Do these two add up to 82? Yes, they do. So we know we must have done this correctly. As always, all the information on these slides has been acquired and adapted from Pearson Chemistry, 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a great day.